So now we're going to cover one example that's going to cover several topics dealing with linear equations. All right, so all I'm going to do is I'm going to give you 2 points. So here's the 2 points, 3, -6, and -3, -2. Now, feel free to work through a problem like this, especially if it was on a quiz or a test, in any order that you'd like. So down here, I see a graph. If you want to start off by plotting those points, so 3, -6, and whatever the other point was, and start that way, and then figure out, okay, what's my slope, and figure out if you have a y-intercept, what that y-intercept is, if it's a nice integer value. Okay, you can feel free to do it that way. If you want to go through the questions that I put in order, you can do it that way as well. I would say be flexible. Depending on the information I give you, be flexible to do it different ways. All right, so here we are given the 2 ordered pairs. So I'm not going to graph it first. Rather, I'm going to use the formula. So here again is our formula. So here's your x1, here's your y1, x2, y2, and then we're just going to plug these values into the formula where they appear. So that's going to give me -2 minus negative. Now, please don't ever leave it like that. Minus a negative, that's telling you that you have a double negative, so that means that you really have a positive value there. All right, so really what we're going to do is we're going to add, so -2 plus 6, and then -3 minus 3, and then we're going to evaluate the numerator and the denominator. So the numerator will give us 4, and -3 minus 3 is going to give us -6. Always, always, always simplify your slope if you can. So that's going to give us a slope of 2 over -3. Now, one thing that I do know that tricks students sometimes is that negative sign. Okay, the slope is negative. Okay, it doesn't matter where you put that negative sign. You can either have it in the denominator, like this one is. You could put it up in the numerator. So the negative could go up with the 2 rather than on the bottom with the 3. But notice that there's one negative sign, just like there was here. Or you could put it out in front. So you could have y, or the m, is equal to, and then put the negative out in front. So all of these are equivalent. 2 over -3, -2 over 3, or -2 over 3. The reason why is there's one negative sign, so the slope is negative, which tells me right now, before I graph it, I'm going to have a slope or a line that looks like this because the slope's negative. So my line's going to be decreasing. So now the next part of this question is to write the equation of the line. Now, normally you're not going to have to do all 3 forms, but for the sake of this example problem, we're going to put them in all 3 forms. And I do not care which one you start off with. So if you like slope-intercept form, start off with slope-intercept form. I, however, will always go to point-slope form first. The reason being is because what happens if my y-intercept is not an integer value? Okay, point slope form, that's always my go-to because I have a point up here. I actually have 2 of them. I get to decide which one I use, right? So I actually have excess information when it comes to point slope form. All right, so here's how this is going to work. So I'm going to start off with what point slope form is, and then I'm just going to replace the values with the values that I know they are. All right, so again, I get to pick one. I'm just going to choose the first point. All right, so 3 is the x-coordinate, so I'm going to replace x1 with 3. -6 is the y1, so I'm going to replace that with -6. Now, wait a second, I'm going to have a minus and negative, so I'm going to actually change that to y plus 6. And then the slope that we just found was -2/3. All right, and there it is. Point slope form is already complete. All right, and then what I like to do is go from point slope form to slope intercept form by solving for y. So again, to solve for y, that means that the parentheses have to go and anything on the same side as y has to go. So I'm going to distribute the -2/3. So negative times a negative is going to become the positive. And then 2/3 times 3, well, the 3 on top, 3 on the bottom is going to cancel out, and that's just going to give me 2. And then I'll need to move the 6 over to the other side. All right, so I'll move the 6 over to the other side by subtracting 6 on both sides. And again, I can't do it to here because that would not be the like term. So 2 minus 6 is going to give me -4. And now this tells me not only is my slope -2/3, but my y-intercept is -4. And then I'm going to go from slope-intercept form to standard form. All right, so first thing I'll do is get rid of the fractions by multiplying everything by the fraction that I had, the denominator, which was 3. So it's going to give me 3y and then minus 2x. And then I was multiplying by 3, so that should be a minus 12. And then I want to get the x and y on the same side. I want x to be positive, so right now x is negative, so I'm going to move it. Had x been positive, I would have moved the y term over and the constant over. All right, but x is negative, so the opposite of a minus 2x is to add, so plus 2x, and then 3 was already positive, so I'll put a plus 3 right there. And now I have an equation in standard form. All right, so all 3 of my forms are here. They give me different pieces of information. I already had what the point was before, and I already had the slope, so this wasn't that helpful. But slope-intercept form, now I figured out that the y-intercept is at -4. Standard form, what I could do is I could solve these real fast to figure out what the x-intercept and what the y-intercept is. So if I let this y value be equal to 0, so if I let it be equal to 0, it means it just goes away. That's going to give me the equation 2x is equal to -12. Well, obviously, I'll need to divide both sides by 2, and I get that the y-intercept, the x-intercept is going to be at -6. To figure out what the y-intercept is, that means that the x-coordinate would have to be 0. And so then that leaves me with the equation 3y equals -12. So to get rid of the 3, divide both sides by 3, and that gives me y equals -4, which I already knew from over here, but that just verifies. All right, so there are all 3 forms put to use. Now it is up to you how you would like to graph your line, whether you'd like to use your slope-intercept form, so by putting your point down on the intercept, which was at 4, and then -4, I'm sorry, it was down here at -4, and then use the slope to move, which was -2/3, so down 2 to the right 3, and then keep going 3, so down 2 to the right 3, and so on. If you want to use the intercepts, you could. So you could plot a point at -6 on the x-axis. You could plot a point at -4 on the y-axis, use a straight edge and connect them that way. Or, going back up to the very top, you could have plotted these 2 points. Okay, plotted those 2 points, and then again, you just get a straight edge and connect them. How? I'm going to show you to graph on this using Desmos. All 3 forms. I'm just going to verify that it doesn't matter which form you put it in, we're going to get the same graph. So here was the point slope form. There's our graph. Here's the slope-intercept form. There's the same graph. And here's the standard form. And once again, it's the same. So this is what our graph looks like. If I focus in, the y-intercept is at -4, and that x-intercept was at -6. So the next part of this lengthy problem says write and graph an equation of a line parallel to the given line through the point 2, 0. All right, so something that we should really focus in on is here, this word parallel. So whether you've taken geometry before or not, you should have heard this word parallel, and it has the double L right there, which is really nice. It just means that you're going to have 2 lines that never meet. Now, why are the 2 lines never going to meet? Well, it's because it means at every point that you have, they're always going to be the same distance apart. Okay, that's more the geometry definition. The algebraic definition is because they are going to have the same rate of change, which means that they have the same slope. So parallel lines have the same slope. So what I'm going to do is I'm going to borrow the slope that we found up above, which was -2/3, and now I'm going to use it with this point right here and write an equation of the line. Now, which form am I going to put it in? It doesn't specify, so you get to choose, so feel free to use whatever one you want to use. I know I'm going to go with point slope form because this is just a random point on the line. Okay, it's not the y-intercept. Okay, so that means I'm going to use point slope form. So here is point slope form, and now I'm just going to substitute values in. So 2 up here is the x value, so I'm going to change my x1 to be 2. 0 is the y value, so I'm going to change this to be a -0, which we should all know that we don't need a -0 there, so I'm just going to have y equals. And then the slope m, again, parallel lines have the same slope, so that was -2/3. And I now have an equation in point slope form. If I want to, now I could put this into the other forms, which I don't think I'm going to put it all the way into standard form, but I will put it into slope-intercept form. So what I'll need to do here is get rid of my parentheses by distributing. So that means I'm going to have negative 2/3 x. And then I'm going to have negative 2 times negative 2, which is going to give me positive. And then that's going to give me a positive 4/3 this time. I didn't have my fraction that canceled out, so I'll try to be nice to you, but I won't always guarantee that I will be. You have to feel comfortable. You have to get familiar with working with fractions. All right, so this tells me that the slope is still negative 2/3, but now the y-intercept is at 4/3. All right, so when it comes to graphing this, I probably would not recommend using slope-intercept form because then you're going to go up 1 on the y-axis and 1/3. So you're going to be in between two values. All right, so I'd say only use those if they're integer values. So instead what I would do is I would plot this point 2, 0. All right, so I'd plot the point 2, 0, and then I would use the slope down 2 to the right 3, and then make my line that way. Let's take a look at this in Desmos and see what they look like. So here I've graphed both lines in Desmos. We have the original line that had the y-intercept down here at -4, and then we have the new line, which still has the same slope, but now the y-intercept is at 1.3 repeating, which was 4/3, and the point on the line was 2, 0. All right, so parallel lines, okay, they're never going to intersect. Why are they never going to intersect? Because they have the same slope. Now let's go back and let's do perpendicular lines. All right, so perpendicular lines means that when they intersect, they're going to intersect to form 4 congruent 90-degree angles. And algebraically, so that's the geometric significance, algebraically, it means that they are going to have opposite reciprocal slopes. All right, so opposite means change the sign, and reciprocal means flip the fraction around. All right, so if you ever have a vertical line, its perpendicular line is going to be horizontal. All right, and horizontal, perpendicular. All right, so that's where the slopes get a little bit different. You're either going to change from 0 to undefined or undefined to 0. All right, but for the positive or negative slopes, these are going to have the opposite reciprocal. All right, so the slope from before was -2/3, so that means that the perpendicular slope, okay, is going to be positive because I have to change the sign. So before it was -2/3. All right, so I'm actually going to start off by writing that down. So the slope before was -2/3. And so then in order for this to become slope perpendicular, I'm going to change the sign. So now I'm going to make it positive, and then I'm going to flip these numbers around. So I'm now going to put 3 on top, and I'm going to put 2 on the bottom, and now here is slope perpendicular. So now I have I have the slope, and now here I was given a point on the line. If you don't recognize it, okay, you would probably start off with your point slope form. However, since 0 is the x value, this tells me that I have the y-intercept. Okay, I didn't come out and tell you straightforward, this is the y-intercept. You have to recognize if the x value is 0, this is the y-intercept. So now I also know that my b is -2. So when it comes to writing my equation on the line, I have everything I already need for slope-intercept form. So slope-intercept form is y equals mx plus b. So now I know the slope of this line. It's the perpendicular slope, so that's going to be +3/2. And then the y-intercept is -2. So I'm not going to do a plus minus. Okay, only one sign. We're in Algebra 2 honors now, so we're going to make that a -2. So last thing that I'm going to do is I'm going to graph this. So y equals 3/2x, and then -2. And I'm going to see now I have a line that is perpendicular. All right, so a rather lengthy example, but it went through several topics that you need to know for linear equations.